Okay, so the goal of this video is going to be simply to go through the problems on page 487, number 16 through 52, multiples of 4, and problem number 45. Woohoo! I heart math. Love it. So each one of these homework problems will be in here, and we will go over, and I will go over each one, and I'm going to provide some insight, but not a lot, just so I can get through this pretty quick. So number 16, our problem is 4k to the third power plus dk squared plus 9k to the third power. What I see here is like terms in the k cubed. So 4 plus 9 is equal to 13, just paying attention to the coefficients. I don't need to worry about the k's or anything like that, so I end up with 13k to the third power, and I still have 6k squared. The next problem, let's do the next problem. It is number 20. So we have 7xy minus 4x squared y minus 2xy. So let's look for the like terms. I see like terms here and I see like terms here. They have the same variables with the same exponents. So to do this math, I have 7 minus 2. That's all I'm paying attention to, just the coefficients. I don't need to pay attention to the variables because they are going to stay the same when I'm just adding and subtracting. So I get 5xy minus 4x squared y. Done. Awesome. Sweet. Finished. Now number 24. Let's go on to number 24. It is 3b to the third power minus 2b minus 1 minus b to the third power minus b. Ooh, lots of b's. This is pretty crazy. So let's pay attention to like terms. We have b cubed, we have b to the third power, and then we also have b's all by themselves. And then there's just this last little guy, this number 1, he's all by himself. All right, so let's do like terms. 3b to the third power minus b to the third. I'm paying attention to this minus because it's technically adding a negative, so that ends up being 2b squared. And then our second one, we have negative 2b plus a negative and plus a negative b. So I can say minus b equals negative 3b. So I still have my negative 1 on the end, so let's rewrite this. I have 2b squared minus 3b minus 1. Done. Final answer. I'll start boxing my answers here. All right, let's go on to the next one. Our next problem I'm going to do in purple, and it is number 28. 28. It is parentheses negative 2z cubed plus z plus 2z cubed plus z, lots of z's, plus 3z cubed, and it looks like I'm going to run out of space, so I'm going to move this, minus 5z squared. First one of those. All right, so let's combine like terms. Let's find all of the ones that are similar. We have 2z to the cubed, or 2z cubed, or negative 2z cubed, and a positive 2z cubed, and we have a 3z cubed. As well, we have a single z, another single z, and that's it. And last but not least, we still have this 5z squared. So, or putting the like terms together, we have negative 2z cubed plus 2z cubed plus 3z cubed. Doing all that math, negative 2z cubed plus 2z cubed, that's going to be 0z cubed plus 3z cubed, so we have 3z cubed. Next, z plus z, 2 z's. Awesome. And we still have that negative 5z squared, so we can rewrite this as all together as 3z cubed plus 2z minus 5z squared, and this is not my final answer because it's not written in standard form, so let's write it in standard form. Here's the first one, 3z cubed minus 5z squared plus 2z. Always make sure you write your final answer in standard form. All right, our next problem is number 32. I'm going to give myself some more space. I'm not sure why. We're on green now. 32. We have 3s squared plus 4s minus a negative 10s squared plus 6s. First things first, I want to rewrite this second equation as adding the opposites. So I have 3s squared plus 4s still, and I'm going to rewrite this as plus 10s squared, positive 10s squared, minus 6s. If I do that, then I'm adding the opposites. So now let's identify those like terms. We have 3s squared, 10s squared, and we have 4s and 6s, or negative 6s. So let's rewrite this as the term, putting the terms together. 3s squared plus 10s squared plus 4s plus a negative 6s, and I can rewrite that as plus a negative. Always rewrite those subtraction problems as plus a negative if you can. It makes it a little bit easier. So 3s squared plus 10s, we have 13s squared plus 4s plus a negative 6s, negative 2s. So it can be written like that, or it could be written as this, plus or minus 2s. Either one works. Both of those are final answer. Next one, 36. So 36 is the following. I think I'm under purple now, I'm not sure. 36. We have 4m squared plus 3m plus negative 2m squared. Let's add these up. Let's figure it out. So combine like terms. I see an m squared here, and I see an m squared here. This m, not the same thing, something different. This is apples and oranges. So let's not make fruit salad. Let's keep these apples separate. So we have 4m squared plus a negative 2m squared. And we have then plus 3m all by itself. So 4m squared plus a negative 2m squared, that equals 2m squared, and plus 3m, it's in standard form, final answer. Our next problem, number 40. Our next problem, number 40, let's give ourselves a little bit of space. 40. We have 2z. Why do they always put 2's and z's together? It makes it so hard to see which one's which. Minus 3z minus 3 plus 2z squared minus 7z minus 1. So let's first combine like terms. Just like before, we're doing an addition, so we can combine like terms. We have 2z squared and 2z squared. Those are the same. We have negative 3z or minus 3z and another minus 7z. And last but not least, we have a constant of negative 3 and another constant of negative 1. So let's combine those terms. We have 2z squared plus 2z squared. Awesome. Then, after that, we have plus negative 3z. I can always write that as plus a negative, and I can write that as plus a negative, plus negative 7z. And then last but not least, we have plus negative 3 plus a negative 1. Same goes for these ones. We can always write those as plus a negative. So 2z squared plus 2z squared, we have 4z squared. Nothing happens to those exponents when we're just adding. Then we have negative 3z plus negative 7z, so we have negative 10z. Awesome. And our last little bit, negative 3 plus negative 1 equals negative 4. So that is final answer, but this is also final answer. 4z squared minus 10z minus 4. So either form of that works. Either form. 44, we have a little bit of a word problem here, and I'm going to take a picture of this, so bear with me. Okay, so this problem is a little bit more in depth than we have space for, so I'm going to try to do it in a small amount of space. But it says, if the parentheses were removed from 3m squared minus 5m plus 12m squared plus 7m minus 10, is the new expression equivalent? That tells me needs to be equal to the original. As well, if the parentheses were removed from 3m squared minus 5m minus 12m squared plus 7m minus 10 is the new expression equivalent to the original. So let's first do this first problem. Let's do this one. So we have 3m squared minus 5m plus 12m squared plus 7m minus 10. If I think about this, do I need the parentheses? No, not really, because we're adding things, and we can always rewrite this subtraction on that 10 and as well as this 5m as plus a negative. So technically, no, it's not going to matter. I'm going to have the same answer as before. So I have 3m squared plus a negative 5m plus 12m squared plus 7m plus a negative 10, which we can then identify like terms and do those. 3m squared plus 12m squared, that's 15m squared, and then we have negative 5m plus 7m, that equals 2m. And last but not least, we have plus a negative 10. So this is equivalent to this. This parentheses, how do I spell parentheses? Parentheses do not matter with addition of polynomials. Now let's look at the subtraction problem. So that's one part of this. Let's look at the subtraction part of this now. So let's see if I can give myself even more space. Even more space than that. So our next part of this problem is this. We have 3m squared plus a negative 5m. I'm just writing it like this right away, so I have that plus a negative already figured out. And then minus 12m squared plus 7m minus 10. So when I'm subtracting something, this is a big indicator to me. This is a big scary sign. So I'm going to rewrite this as plus a negative. And if I do that, I'm essentially multiplying by negative 1, by negative 1, by negative 1. So I'm adding the opposite. And I have a feeling if we're dealing with something like that, to get rid of those parentheses, I have had to change every single one of oops, I wrote that wrong. Every single one of these operations in the second equation. So those parentheses, that tells me that that parenthesis matters. So let's look and see what we have going on. If I have 3m squared plus 12m, or negative 12m squared, I have negative 9m squared. And then I'm doing the same thing with these m's. We have negative 12m. And last but not least, we have plus 10. Alright, so I don't know exactly what happened to my information that I had right there, but I had the answer essentially negative 9m squared minus 12m plus 10. Our job now is to figure out if this is equivalent to if we had done it without doing that distributive property thing. So we have 3m squared minus 5m minus 12m squared plus 7m minus 10. Now you might be saying, Ms. Beardsley, you didn't distribute that negative in there. Well, exactly. What the question is asking us is we need to figure out what this second half would look like if we just took away the parentheses, not distributed that negative in there or anything like that. So if we just took them away, is this going to equal the same as this? So by doing that, let's find our like terms. We have 3m and minus 12m, and we have negative 5 plus 7m, and we have our minus 10. So looking at that, I already see a minus 10, and I don't like that. I want to see a plus 10. But I have 3m squared minus 12m squared equals negative 9m squared. So that was the same. That's kind of cool. Now let's look at negative 5m plus 7m, and we have 2m. Different. different answers. And we have negative 10. So if we were to rewrite all of this, we have negative 9m squared plus 2m minus 10, and that is a different equation. And because of that, no, the parentheses, I probably spelled that wrong, need to be there to show you, or encourage you maybe, encourage the distributive property. Without that distributive property, without that transferring that negative 1 to each one of these terms, the 12m, the 12m squared, the 7m, and the negative 10, we will have a different answer. So the parentheses matter, or do not matter for addition equations, but they do matter for the subtraction equations. That's a big takeaway from this. Okay, our next problem deals with the table, so I'm going to take a quick picture, so bear with me. And let me actually make myself a little bit of room. Okie dokie, this next problem we need to copy and complete the table by finding the missing polynomials, and we're looking specifically at 48. So we have polynomial 1, we do not know, so we have a missing amount. Polynomial 2 is 5x to the 4th plus 8, and if its sum, so that's why I did addition, is equal to 6x to the 4th minus 3x squared minus 1, we need to figure out what this missing polynomial is. So let's work backwards a little bit. We're going to need to subtract this from this. So we have 6x to the 4th minus 3x squared minus 1. Let's work backwards and subtract 5x to the 4th plus 8. Essentially, we are balancing this by subtracting 5x to the 4th plus 8 from this side and putting it over to the other side of the equation. So let's combine like terms. I see x to the 4ths and I see constants. So these x to the 4th, 6x to the 4th minus 5x to the 4th, we get x to the 4th, 1x to the 4th. We still have a negative 3x squared, and our last one is negative 1 plus, negative 1 plus a negative 8. Negative 1, I'm saying plus because we're going to distribute that into here and say that's actually a negative. And before we had the negative 5x. So negative 9. So our missing polynomial would be x to the 4th plus a negative 3x squared plus a negative 9. Or x to the 4th minus 3x squared minus 9. Either one works, but if we were to put that together in here, x to the 4th minus 3x squared minus 9, and add them up, we can see negative 9 plus 8, that'll get us a negative 1. Negative 3x squared, there's nothing to take away from it, so we still have a negative 3x squared. And x to the 4th plus x to the 5th, 6x squared. So here is our final answer for that. 52. It says here, does the order in which you add polynomials affect the sum? Does the order in which you subtract polynomials affect the difference? Explain. So let's talk about this one. I'll give us a little bit of room and let's actually look at this in a little bit of different light. So does the order in which you add polynomials affect the sum? So if I were to add 6x squared plus 2x plus, or squared plus 4x squared, just random numbers, I'm just picking random things. 6x squared plus 2x squared plus 4x squared, I should get 12x squared. Does it matter if I did the 2x squared plus the 4x squared plus the 6x squared? Let's see. 12x squared. Nope, doesn't matter. Adding doesn't matter with order. Now let's see if we can use those same polynomials and do subtraction in any order. So 6x squared plus, or minus 2x squared minus 4x squared. Let's see if this 6x squared minus 2 is going to be 4, minus 4 is 0x squared. Let's see if we end up getting something different. What if I said 4x squared minus 6x squared minus 2x squared? So I'm just putting these numbers in a different order. So 4x squared minus 6x squared, that's negative 2, minus negative 2, or minus 2 is negative 4x squared. Order matters with subtraction. That's what that tells me, because I get two different answers. However, I can guarantee you if we had written this as negative 4x squared minus 2x squared and kept that 6 a positive plus 6x squared, we'd end up with 0. But at the same time, that's not what this question was asking. It was asking the order in which we subtract the polynomials. So just taking those numbers and seeing if they add up to be something different, if that ends up being different. All right, one last problem and we're done. So for this problem, we have an error analysis situation, so I'm going to take a picture of it so we can talk about it. One last thing, take a picture, hold on with me. All right, so for 45, two students found the sum of polynomials, negative 3n to the fourth plus 6n to the third plus 4n squared, and 8n to the fourth minus 3n squared plus 9n, which is incorrect, and explain the error. So we have one student, well, both of the students did it vertically. One student did this. We have negative 3n to the fourth plus 6n to the third plus 4n plus 0n. That's interesting. And then we have a 0n to the third. I wonder why they did that. And this other student did this. So let's actually do the work ourselves and really figure out what's going on. We have negative 3n to the fourth plus 6n to the third plus 4n squared minus, oh, this is plus, sorry, 8n to the fourth minus 3n squared plus 9n. So let's combine our like terms. I have an n to the fourth, n to the fourth, n to the third. Oh, we don't have an n to the third in this second one. Maybe that's why this student said 0n to the third. That's interesting. And 4n squared minus 3n squared, and we have our last and final thing, 9n, and maybe that's why they have the 0n there. Interesting, interesting. So looking at that, I'm kind of leaning towards A is correct, and so B is incorrect. So, but let's do the work. Negative 3n to the fourth plus 8n to the fourth equals 5n to the fourth. We then have that 6n to the third, 4n squared minus 3n squared. I could also have written that as plus and negative, doesn't matter. And that equals n squared. And my last one, we have that 9n. So this can all be written as 5n to the fourth plus 6n cubed plus n squared plus 9n. That is what student number 1 did. So B is incorrect because they added unlike terms together. So they added unlike terms together, therefore B is incorrect. All right, so check your homework. Hope this helps with understanding some of these problems. I hope you guys were able to find the problems okay and that sort of thing. And have a happy day with Ms. Rupert. Ciao.